Mountains. This is the town of Apatiti. This is the town of Kirovsk. This, if it works, oh yes, there's a blow up. So there's the big quarry. Very easy to discern. Oops. There's another example. This is the area around Norilsk, the horribly polluted place. This is another false colour infrared image. So red is vegetated, bluey grey is not vegetated for whatever reason. So this is the city of Norilsk, plus some of the mining operations. Here is a stable smoke plume. In fact, that stable smoke plume has been traced in suitable satellite imagery over a distance of 600, I forget whether it was kilometres or miles, anyway, an awfully long way in coarse resolution imagery. Land cover, pretty easy to identify. Here's another example. This is a sediment plume. This is another tailing pond. And there is some escaped tailings making their way into a lake, which they shouldn't really be doing. Okay, last topic, energy production. Energy conversion, burning fossil fuels, mainly fossil fuels in the Arctic, to generate electricity pretty much maps to population. It happens where people are, for obvious reasons. It's not a particularly good thing to do. It liberates heavy metals, sulfur dioxide, various oxides of nitrogen. But as I say, it mostly happens close to the point of consumption, so it happens where people happen. And in fact, compared with smelting, it's not huge. The total SO2 emission for the entire ABAC region is estimated at about 300 kilotons. So compare that with the couple of megatons that we get from Norilsk, for example. Nuclear power, I don't really have anything to say about. We can't really monitor it from space. It's not a huge issue in the Arctic. So where the people are, it's quite easy to work out. So all these spots are anywhere in the Arctic. I've got a kind of rather Catholic definition of the Arctic here. I've decided to include Iceland in it. Anywhere there's a town with a population of more than 20,000 people. So you can see how that works out. A little bit in Alaska, there's quite a bit in North Europe, and then there's Norilsk, and this is Vorkuta and Salakhard, probably. Not sure. And that's it. Now, more interestingly, extraction and transport. This is a significant source of pollution. The Arctic is a major source of oil and gas. And it's not the easiest stuff to extract safely. I think there's been a recent demonstration of that, actually, not in the Arctic. And the scope for spillages and leaks is, again, not good. And the situation between the Western and Eastern hemispheres is very, very asymmetric here. Here, well, I've slightly obliterated the diagram for the North America with the diagram for Russia here. But you can see there are essentially two main extraction areas. Here, the Bay and Bent Hornfield, and a very modest array of pipelines that bring the stuff south. In Russia, the situation is that there's much more going on. There are lots of pipelines, lots of developed fields, more fields being developed now, and, well, what can I say? The North American pipeline system is pretty good. The Trans-Alaska pipeline works very well. The Russian network is not always in such a good state, shall we say. There was a very serious terrestrial spill in 1994 near a town called Sinsk, which in units of the Exxon Valdez oil spill probably counted at about 8 of them. Amazingly, the amount of environmental damage that caused was quite modest, because most of it won't make its way into the Victoria Delta, but it could have been catastrophic. The problem is building these structures in permafrost. Permafrost is an unstable mechanical material. It heaves around, and if you put something fixed like an oil or gas pipeline into it, Firstly, it has a tendency to conduct heat into the permafrost and destabilise it. And secondly, it tends to react rather unkindly to mechanical stresses applied to it. So pipelines can be heaved. This one is still functioning. I mean, this is still transmitting the gas, I think, that it is supposed to transmit, but it's obviously it's got a little bit warped. This one too. So it's a pretty tricky thing to do, and in the West it hasn't been done that often for that reason. Here, what can remote sensing do? Well, actually, we're not quite sure yet. This is an interesting area for research that hasn't been explored very well yet. Obviously, you can detect spill directly. If a spill has damaged vegetation, you know remote sensing is very good at detecting damaged vegetation, so you can do that. It might be possible to detect changes in the thermal regime of permafrost using infrared data. It might be possible to detect oil-soaked ground using radar methods. It might be possible to detect thermocast phenomena, perhaps using radar, but this has not really been looked at in much detail at all. So that's an interesting area to develop. So I just show one example which doesn't show an oil spill, but nearly did. This is a spot, that's a French satellite system, false color infrared image of the area where the Usinsk oil spill happened. This is drill pads. This is the River Kolva, which is a tributary of the Usinsk is just down there. And you can actually see the line of the pipeline as a linear feature here. It's somewhere where there isn't vegetation along a linear axis like that. The spill happened there, and actually most of the spilled oil made its way to that ledge and didn't make its way to this river. So that isn't a picture of an image of an oil spill, and that actually illustrates a point that I made before about the timing issue. You generally can't control the timing of a satellite image, you just get it when you get it, and this was a few days before the Usinsk oil spill. How marvellous it would have been if that image had been a few days after the oil spill. So that's all I'll say, really. In general, remote sensing is a pretty powerful technique for monitoring the environmental state of the terrestrial Arctic, but there are limitations. There are some things we don't know, and there are some things that we know that it still finds quite